So for page 91, title it Solving Exponential Equations. And so this is what your page is going to look like in the end. So you're going to paste your flow chart that we have here. And so we want to be able to solve exponential equations that look like these two. And so we have a question that we ask ourselves first from the very beginning. And that question is, can you make the bases the same? In the case the answer is yes, you follow these first two steps, 1 and 2. In the case the answer is no, you'll follow these 3 steps here. So I have an example for both of them. In this first one, we have 4 to the x minus 2 is equal to 1/8 raised to the 2x minus 4. So I want to solve for x such that when I plug it here on the left, I get a number, and when I plug it here on the right, I get the exact same number. So when we go to do this, we're making the bases the same. What can I change this base of 4 and this base of 1/8 so that they're the exact same base? In this example, that number is going to be 2. So for example, 4 can be raised to the 2 power, so I'll rewrite that as 2 squared. 1/8 can be written as 2 to the negative 3 power, so I'll rewrite that 1/8 as 2 to the negative 3. From there, I'll use my rules of exponents. And so when you have an exponent raised to another exponent, you actually multiply those two exponents. So I'll multiply 2 by x minus 2 to get 2x minus 4. And then I'll multiply negative 3 by 2x minus 4 to get negative 6x plus 12. Now, this number right here should not be a 4. Please go ahead and scratch that out. I don't know why that's there. Scratch that out and make that a 2. That should actually be a 2 there instead of a 4, so I apologize for that. Now, since the bases are the same, we have 2 to the 2x minus 4 equal to 2 to the negative 6x plus 12. If the bases are the same, we can now do step 2, which says to set the exponents equal to one another. I'll completely ignore the bases at this point and work with only the exponents. We have 2x minus 4 equals negative 6x plus 12. You'll add the 6x to the left to get 8x. You'll add the 4 to the right to get 16. And then you'll divide both sides by 8 to get x equals 2. On the next side, we have an example. Oh, by the way, we should plug this back in just to make sure that it works. So if I plug in 2 here, 2 minus 2 is 0, 4 to the 0 is 1. So on the left, we have the number 1. Over here, we have 2 times 2, which is 4, minus 4 is also 0, and 1/8 to the 0 is also 1. So this answer does work. On the right side now, it says if you cannot make the bases the same, for example, in this case, we have 3 to the x plus 1 equals 9. The first thing I'm going to do is step 1. I'm going to isolate the exponential terms. I'll subtract the number 1 from both sides. So I have 3 to the x equals 8. In this case, we cannot make the base of 3 be equal to the base of 8. So we're going to do step 2 now. It says take the log of both sides. You could technically take the ln of both sides as well, and that would give you the same answer. So when I take the log of both sides, I'll get log of 3 to the x set equal to log of 8. Remember that power property of logarithms allows you to take this x as an exponent and bring it down as a coefficient now. So I have x times log of 3 equal log of 8. We'll divide both sides by log of 3 to get an answer of log of 8 divided by log of 3. You plug that into your calculator and your decimal would be 1.8927. At the bottom of your notes, it says, note, you can use a log with any base. And so this is what I was talking about here. Up here, I could actually use the ln instead. So if I come over here and I redo this same exact example, then I have the ln of both sides. The natural log of 3x is equal to the natural log of 8. Same power property, I'll bring that x down in front. So I have x natural log of 3 equals natural log of 8. You'll divide both sides by natural log of 3. So your answer is natural log of 8 divided by natural log of 3. This looks very similar to the answer that we got before. The only difference is this had a log base of 10 in my previous answer. This one now has a base of e on my answer. But regardless, if I plug this into my calculator, I still get that same 1.89, which is the answer that we had up here as well. Now, I did this example a third time, and now I'm actually using the log base 3 on both sides. So if I do log base 3 of 3 to the x, and I set it equal to log base 3 of 8, I can bring that x down in front again. Log base 3 of 3 is equal to 1, so I have 1 times x. And then I have on the right log base 3 of 8. Now, your calculator does not allow you to do this unless you have the black calculators. So if you have the black calculators, you could actually type this in using the log. You'll put in a base of 3 and then an 8 here, and you hit enter and you will get 1.89. In Desmos, however, you can calculate this for those of you with the gray calculators. If you just go into Desmos and you type in log, you'll do the shift button and then the underscore button, which is right around the 0 or the 9. I'm not sure which one it is. And then you'll type in A. So log, shift, underscore, and then you'll put the 3 in there for the base, and then 8, and then when you hit enter, you'll still get 1.89. So regardless of which base you use on the left side and right side to solve this, you'll end up with the same answer every single time. This is due to a formula called the change of base formula. This is actually on the next page because I ran out of room here, so we'll put that on the next page and talk about that on page 92, I think it is. All right, but as far as this page goes, that is it for this page.